Hello, it's Keith here, and this is lesson 5 of my YQuest Z80 assembling programming tutorials. Now, in this series, we're looking at this little game I wrote during my live streams. It was originally written for the Amstrad CPC, but I'm porting it to a lot of different systems. This is the MSX2 version. It's a remake of an old DOS game called YQuest, which I believe was a remake of a Mac game or something. I'm not really sure. But anyway, it's a little bit of fun, and it was based on the code from my Super Simple series, the joystick code, where we moved to Smiley. Point being that you can actually make something half decent from a relatively simple basis. I can't play it, obviously, because I only wrote it, but anyway, as I say, point is, you can make something a bit fun that you can be pretty proud of, hopefully. Anyway, we've been going over the common code that's common to all the platforms, and once we've done that, we're going to go over the platform-specific code. Anyway, let's go over the last part of that common code this week. So, first we're going to be looking at the object collision routine. This is the routine that tests if an object has hit the player, as you can see just in the comments here, because I've actually commented my code for a change, which is maybe rare. Anyway, the first thing we're doing is we're checking the collision program. Now, the collision program controls what happens when the player hits an object, but if the collision program's over 250, it means the object's dead or never been initialized, in which case it has no effect on the player. So we're checking that first. Then what we're doing is we're loading the player XY position and also the object X and Y position, because when we run this, we pass the object we want to test with the pointer IX here, the IX register. Now, you'll notice there's some code here with these collision masks. Now, this is something I've added very late in the code. I actually had to add this to parts of the code we looked at previously. This part of the code has actually been changed. What I'm doing here is I'm masking out part of the X and Y position of the player and the object, and the reason for this is some systems where I'm using the tile map to draw objects to the screen are always going to move in 8x8 chunks, even though the actual resolution of the gameplay is higher. So an object might look like they're separate on the screen, but according to the game's internal positioning, they might be overlapping, and this would mean that the player hit an object when they didn't realize they were going to. And so I've added these masks in to basically mean that if we're only showing the objects in an 8x8 block resolution, we're only comparing at that same resolution so that there's no risk that the player will collide with an object that it looks like they're not going to. So that's a little addition there, unfortunately, at the last minute. But then we're using the range test routine, which will return a carry clear if there is no collision, or a carry set if the player has collided with the object. Now, if the player has collided with the object, we then need to see what should happen, and it depends on the collision program of the object. A collision program of 0 means that the player can be hurt by the object. It means essentially the object is an enemy, and so we run the player hurt routine. If the program is a 1, however, that means that this is a crystal. So we're now going to process the crystal receiving routine. We remove the current crystal, we give the player some score, we make a nice sound effect, and we decrease the number of crystals that are remaining on the level. Now, if the crystals have reached 0, then we've completed the level. Well done us. Otherwise, what we're doing is we're checking if the number of on-screen crystals is greater than the number of remaining crystals, because some of the levels have up to like 30 crystals, but we're only ever showing 5 on screen at a time due to graphical limitations. Some of the systems can't draw sprites that fast. So what we're doing is if we want to show 5 crystals on screen and we've collected one of those 5, but there's still 10 left to collect, we're respawning that 5th crystal in a new position. And that's what we're doing here. We're using the randomization routine here to put the crystal in a new position, but we're using this safe randomized object position to make sure that the crystal isn't overlapping a mine or something, in which case it'd be impossible to collect. And so that's what we're doing here if we've got a crystal. If the crystal is one of the last 5, so we don't want it to come back, then we're changing the object program to 255, which defines the object as unused. That's why we're comparing to 250 here. 255 means an object that's unused. 254 is a dead enemy that's going to at some point in the future respawn. So that's the crystal routine. The only other object type that the player is affected by is enemies, basically, and so these hurt the player. Now, first we're checking if the player is invincible, which would mean this invincible counter was greater than 0, and if they are, we're just ignoring the hit. Otherwise, we're going to stop the player moving. So we change the acceleration to 0, and then we do a crude little animation of the player exploding here, which I tend to see quite a lot because I'm quite bad at this game, even though I wrote it. The animation for the death is sprite 5, so we're setting the player object to sprite 5 here. and then we're manually cycling the player animation through the 4 frames of animation here. You can see we've got A being used as a counter here, and we're just showing each of the 4 and making a noise effect being affected by that A counter as well. And so this is just a very simple death animation here, nothing too special here. Then we reset the player position. We then silence the sound. We check the lives. If the player has no lives left, then the player's dead. If the player's got any lives left, we just decrease them by 1 and reduce the counter, and then we return here. Now the player dead routine here will be executed if the player has no lives left, in which case we're just showing the you're dead message. Next, what we're doing is we're checking to see if the current score is higher than the high score, and we're using this BCDCP routine that we looked at in the multi-platform series. If the player has no new high score, we're skipping down to here and we're showing the press fire and jumping back to the title. If the player has got a high score, we show that they've got a new high score message, and then we copy the player's score over the high score in memory here, the 4 bytes of the player's score. Now, once the player has collected all of the crystals on a level, we were checking that just here, if the remaining crystals reach 0, we need to move to the next level. So we show a message saying you've level complete. We then give the player a bonus life because they've done well, increase the level number by 1, and jump back to the start of the level routine here. So that's the end of the crystal collecting routines. You know, the next level routine is part of the crystal collecting. And here's the death routine for if the player's been hit. But what we need to do now is have the bullet routines. So when we want to fire a player bullet, we're doing the following sequence. Firstly, we're looking for a spare slot in the player's bullet array. There's a total of 8 slots, and these are defined by an object of 255. So once again, we're cycling through the bullet array. We're checking all 8 bullets. The bullet count is 8. We're reading in the collision program, and we're looking for one that's lower than 250 because 255 is an unused object. And if we find it, we're jumping to this routine here. But if we haven't, we're just moving to the next bullet until we've checked them all. Now, if the player's used all 8 bullets, if there's 8 bullets on screen, we can't fire. But if we can, then what we're doing next is we're making a little sound, and we're then setting the acceleration of the bullet. Now, the bullet moves at a constant speed. The X speed is 4 or minus 4, and the Y speed is 8 or minus 8. This is a constant direction, but the resolution of the X direction is sort of half what the Y one is, so that's why there's that discrepancy there. But we're checking basically if the X and Y acceleration of the player is positive or negative, and we're setting the acceleration of the bullet accordingly. So the bullet will fire in the same direction as the player, but it will move at a constant speed. The speed isn't being passed on from the player. You could make it do so if you preferred. I mean, that might be a change you would want to make, but that's not the way it's currently working. So we're setting the acceleration here, and then what we're doing now is we are then loading in the acceleration, and we're checking if the bullet is firing in any direction. If it's not, then we just skip firing the bullet because we don't want a static bullet on the screen because it would never leave the screen. And then what we're doing next is we're setting the position of the bullet, which is the starting position of the player, setting the bullet sprite here. We're setting the newly decided acceleration, which of course was based on the player's acceleration here. We're setting the program to 0. The program doesn't actually matter for player bullets. And then we're setting the collision program to 3 here, which is a bullet in this case. And then we're just returning here. Now, the fire bullet routine for the enemy is basically the same. Enemy bullets fire a little bit slower. That's the only real difference here. They use a different array, so the enemies can fire 8 bullets and the players can fire 8 bullets, but the player can't fire 16 bullets and then stop the enemies from firing. That'd be silly. So we're using a different array here, and we're just doing the basic same thing, looking for a slot that's unused, a slot with a collision program less than 250. And then when we find one, we're making a slightly different sound. We're firing the bullet, but the speed is half what the player bullets were. We're using a different sprite as well, but basically, apart from that, all of this code here is basically just the same. And that's really all there is to it. We've actually gone over all of the multi-platform code now on this series. All that's left to look at is the platform-specific code, which is the routines that set up the screen, initialization basically. The code to copy the sprite data to VRAM as required, the routines to read in the joystick, and the routines to draw the sprites. That's all that's left that we've not looked at, and that's the part that's very much the same as we saw in the simple series at the joystick routines. Now we're going to go over those in following episodes, and we'll see how the code differs depending on the platform that you're interested in. Anyway, that's all we're going to be looking at today. I hope you found this interesting. If you want, please go to my website, get the sources 7-zip, and you'll find these YQuest examples in there, and hopefully you can have a go with this game and maybe you can make something better out of it. I'm sure there's plenty of potential to do that. Anyway, whatever you do, I hope you enjoy programming and I hope you have a lot of fun. Thanks for watching today, and goodbye.